I'm lifted up, right? Because the weight is no longer equal. So what do we need to do to make these people equal again?
Take the same bag of rice journey.
Good. So we can either put the same weight here, which is 10 kilogram, or we just remove this weight again, right? But what we are trying to illustrate here is that if you are going to put 10 kilogram on this person's head, according to the rules of algebra, if you do one thing on one side of an equation, let's assume this pivots, the wood, the log they are sitting balancing on is equal to sign, you must also do that same thing on the other side. If you do that, the equality between this side and this side will be maintained. If you are multiplying over here by any number, you must also do what? Multiply by that same number over here. If you are adding something here, you must also do what? What must I also do over here? You must also add the same number over here. Okay? So it's almost like you keep adding or reducing or multiplying or dividing, doing things, but maintaining that equality every step. If you keep doing that, you will be able to expose the number that is hidden in the x without damaging this equal sign. So you want to make sure whatever you are doing, this equality is maintained. Okay? So for example, you said we can divide both sides by 2. If we divide here by 2, it's like almost dividing the rice she has by 2, you must also divide here by 2 again, right? So then their weight will remain the same. So if we divide here by 2 and we divide here by 2, nothing changed in reality, right? It's still an equal situation we have. So we know 2 can go into itself once, it goes into itself again once. So we have 1 divided by 1, which is just 1. Okay? So then we have now isolated the x on one side of the equal to sign. Right? But because we have done it here, to maintain that this equal sign, we must also do it here. So we know 2 can go into itself how many times? 1 time. Right? And 2 can go into 6 how many times? 3 times. Right? So 3 divided by 1, it's like almost how many times 1 goes into 3? It's just 3 times, right? So therefore, x equals 3. So this number that was here, that we didn't know, was 3. And you actually said 3, right? Now, this is a simple example, but it's to illustrate to you that if you know the rules, you follow those rules, and you get used to them, you'll be able to solve problems. Okay? And so don't blame yourself if you see maths as looking difficult. It's either maybe you missed practicing those rules when you were in lower stages. So now you are up here, we expect you to deal with SS level maths, WASSCE maths, but there are so many missing things that you needed in those other levels that you don't have. Okay? So that's just one example, right? Now that same thing you can apply, that same idea, solving simultaneous equations and so many different types of equations in many topics in maths, just with those ideas. Okay? Now, let's turn our attention to just numbers and equation in general. Do you guys know about the topic called set theory? Set theory? Anybody knows what a set is? Sorry? Yeah? What do you think it is about? When you're dealing with set theory, you would often see this rectangle. Okay? and sometimes square, but it's just you are representing different sets, right? Or also they are called collections. So often when you see maths classes, set theory is covered right at the beginning. And the reason why it's covered is because many topics in maths have a lot of their foundations, or you can, maths is like a series of arguments for many different things, many different ideas about numbers, okay, and their relationships. So set theory, many of those things can be proved using set theory. And set theory has its foundation in the idea of well-ordered collections, right? So for example,